Yeah, we're actually very excited. So this week at ISE, we've announced that Lenovo is now the top provider of supercomputers on the top 500 list. So we have more listings than any other vendor out there. In fact, nearly 1 in 4 supercomputers in the world today are Lenovo systems. So we're very excited about that. Not only are we doing well at the high end, but we're also taking that investment, that engineering that we do for our biggest customers, and we're moving that down to our smaller customers. So even if they're only buying 4, 12, or 16 nodes, they're still getting some of the power of a supercomputer. So on the top 500 list, one of the things that we're most proud of is this mixture of systems that we do. We don't do a cookie cutter where it's one topology and we sell it to everybody. We custom design every one of those systems for the customer's specific needs. So right now, here in Germany, we've designed a directly water-cooled system. In Italy, we do a hybrid cluster that mixes accelerators and traditional CPUs. In Barcelona, it's a next-generation CPU cluster. And over on the other side of the Atlantic, we've got our SciNet cluster, which is one of our other big ones. It deploys a first-of-its-kind Dragonfly networking topology that's very unique in the world. So we really customize the designs of our systems to what our users are needing in their hardware. To talk about Neptune, I've got to take a step back in history. So in 2012, or a little before 2012, we were approached by LRZ down near Munich, and they had a challenge for us. They said, we're spending way too much for power consumption in our power bills. We want to find a way to drive that out. So we presented to them this idea of bringing warm water to the supercomputer to cool it. And that idea has turned into something that we now sell globally. And it's become kind of the core fundamental architecture of this Neptune technology that we announced this week at ISE. It's smart ways to use water inside of the supercomputer, inside of the server, to drive better efficiency in thermals, better efficiency for the data center. So we've got the direct water cool that LRZ is using, and we've pioneered with them. We've got a rear heat exchanger, which basically is just a giant radiator that fits on the back of a rack that takes the heat from traditional servers and removes it from the data center in the form of water instead of pumping air around in air conditioning. And then we've got a really unique technology called the thermal transfer module that actually uses water, but it uses water in kind of a hidden way. We hide it inside of a heatsink, inside of the server. So the server itself still air-cooled, but the customer gets the benefit of water cooling inside of that heatsink. So really exciting. We think we've got the most holistic approach to liquid cooling in the industry. Well, I think one of the big things that's happening right now is a change in how customers do processing. Traditionally, the Xeon processor, it does 95% of all workloads well. The GPU, on the other hand, an accelerator, it does a very narrow band of things, but those narrow band of things it does extremely well. What we're seeing happen now is more and more workloads are taking advantage of the unique architecture in that GPU. The software environment is getting more inviting, so we have more people working on GPUs. So we're starting to see them be less of a niche product and more of a mainstream offering. So I expect to see a lot of accelerated computing as we go into the future. Things like AI, artificial intelligence, those workloads are perfectly suited to what an accelerated GPU type architecture can do for us. That mixing of AI and HPC, I think that's one of the big trends we're going to see.